Hello students, we are almost finished with chapter 1 and 2, and Varvade sir today conducted even a Google Meet lecture in which he solved all the problems on chapter 2, correct? So it's my duty. I'll begin with chapter 3 now, which is vector algebra. Then we'll go to vector analysis, and Varvade sir will start with the differential equation, that is the last chapter, correct? So we being teachers, we are trying to help you out a lot in taking every topic sincerely. We are trying to upload the videos, trying to conduct lecture. Even I am planning to take your Google Classroom, Google Meet in just 1 or 2 days time. Okay, only one small request. Take it little more seriously because you might have exams in the next month. Timetable will be announced very shortly. So you have very little time. So please be little more serious now. Try to watch the video carefully, solve the problems, practice by which you will be able to score better marks in your examination. Correct? This chapter also is very interesting. If you have difficulty, please tell me when we have a lecture, when I'm going to conduct a lecture, or even you can WhatsApp me on my number. I'll be able to help you out. But don't keep the difficulties with you, correct? That will not help you at all. That's the request, correct? So in this chapter 3, chapter's name is vector algebra. Correct? In this introduction, first is vectors and scalars. So first, as you are studying this vectors and scalar from your junior college days, okay, everybody knows the definition of a scalar. What are the definition of a scalar? The definition of a scalar is the physical quantities, correct, which depend only on magnitude and no directions. Are these quantities are called as scalars. What are the examples over here now? Example is mass, temperature, pressure, time, etc. Correct? Now these, if the physical quantities which are scalar have got the same unit, you can add them, subtract them by normal laws of algebra. Correct? There is no problem as far as addition subtraction is concerned whenever you have scalars. But you talk about vectors. What are the vectors now? Vectors, these are the physical quantities which are described by direction also and magnitude also. Both, then these quantities are called as vectors. What are the examples over here in vectors? Anybody knows? So you can consider simple example is displacement. Then comes which is called as velocity, acceleration, momentum, force, etc. There are many examples which one can give as far as these vectors are concerned. For these vectors, okay, there are certain rules to be applied whenever you want to add them or subtract them. Correct? Even that we are going to study in just next after 1 or 2 topic get over. Correct? So it's simple, but scalars definitely you can add them. Suppose you want to add time, 5 seconds plus 3 seconds. You can say 5 as unit is same, so definitely you can say 5 plus 3 is 8, correct? But as far as vectors are concerned, you need to apply certain rules, then only you will be able to do that, correct? Okay, then comes what is called as geometrical representation. Geometrical representation of a vector. Correct? You want to mention this. So how will I show? I'll just show normally. This is my x-axis, this is y-axis, this is 0 origin, and suppose I draw a point P over here, correct? And say that this is my vector A. Correct? So how will I say? I'll say that vector OP, usually vector is drawn with an arrow on top. So vector OP is same as vector A in my xy coordinate system. Correct? That's as simple. Next we'll see what is called as, and whenever you want to talk about the modulus will be given by this fashion or simply a vector A. Both way you can say the modulus of vector clearly. That's what is the idea behind describing a vector is concerned. Correct. Next we'll see different types of vectors now. So we'll see simple types. First name is unit vector. So what is unit? Unit is 1, correct? So the vectors which have magnitude of 1 will be called as unit vectors in short. How will you represent them? You must have heard this word that I, J and K are the unit vectors along X, Y and Z direction respectively, correct? Next, how will you write that vector? You can write the vector A is equal to n cap into A, correct? What is n cap now? A unit vector is also written as, it's called as vector A divided by modulus of A, which is magnitude, correct? Or simply we can write vector A by A. So this is also correct. This is also correct. This is the way one can simply represent your unit vector. Second will be zero vector or null vector. Okay, as the name says, zero vector or null vector means what? Suppose I say that my vector has starting point is this and I gone on this axis, so I say O to P, so I name it as OP. But in case of this zero or null vector, when the initial point and the final point is same, that is called as a zero vector or null vector, correct? So in short, this is your zero vector or null vector. Now how this zero vector is helpful for addition of vectors? Suppose I say I have a vector A plus vector 0 will give me the same vector A, correct? But if at all I try and multiply it by the 0 vector, then I will get 0, correct? So 0 vector, when it is added to a vector, gives you the same quantity, but when you multiply by 0 vector to any vector, you get 0 only, correct? Next comes what is called as, I should say, 0, correct? Next is equal vectors. Equal vectors. So when we can say, suppose you have two vectors, correct? Suppose you have two vectors like this, right? Everything is same. Direction is same, magnitude is same. So it's easy. Suppose I mention this to be my vector A and this to be my vector B. When will I say vector A is equal to vector B? When both these vectors have same magnitude and they are moving in the same direction. That time I can say vector A and vector B are my equal vectors, correct? Next is, definition is negative vector. Okay, now what is positive vector? Suppose you say, as I mentioned here, so this is point O, point P, suppose I call it as vector A, but this is in minus direction, opposite direction. So I will say that in that case, that to be minus A. So a vector having direction in the opposite sense, then you can call the vector having same magnitude but opposite direction. That time you can use this term called as a negative vector. Correct? Next is concurrent vectors. Now what are the concurrent vectors? Concurrent vectors are the vectors having the same origin. For example, I have one vector in this direction, other in this direction. Vector A and vector B. Correct? I have vectors A, OP, vector B, vector OQ. Correct? But starting point is same, then they are called as concurrent vectors. Next is like vectors. L-I-K-E. What are these like vectors? Like vectors, the vectors which are collinear. The vectors which are collinear and have same direction. Correct? Same direction and they are collinear. Next will be unlike vectors. So as the name says, they are not alike, they are not like, which means one in this direction, other will be in this direction. So collinear, but they will be in the opposite direction. That's what will be the definition as far as unlike vector is concerned. Right? Next definition is coplanar vector. The vectors which are in a same plane. Correct? A system of vectors lying in parallel planes. Lying in parallel planes will be coplanar vectors, and the last definition will be non-coplanar vectors. This part will be important to you when we'll define what is called as scalar triple product or vector triple product. That time I will come back to this term very clearly. So definition over here is a system of vectors consisting of 3 or more vectors which cannot be made to lie in the same plane. They will be called as the non-coplanar vectors. Correct? Then we'll go to the next topic, which is called as rectangular. So again I'll revise one: unit vector, then we have the null vector, then we have equal vectors, negative vector, concurrent vector, then like vectors, unlike vectors, coplanar vectors and non-coplanar vectors. Correct? Then we'll go to next topic, which is called as graphical or rectangular components. Rectangular components of vector. Rectangular components of vector. So how can you say so? Suppose you have x-axis, you have y-axis. This is origin, this is one vector. Correct? So how will I show the vector? I'll show this is O point, this is point P. Correct? I'll show this to be my vector A. Correct? Then I'll try and drop perpendicular on x-axis also and y-axis also. Correct? So these are going to give me my AX and AY. Correct? So how can I write vector A? I'll write vector A as AX plus AY. What are these AX and AY? These are the X along X-axis. So I gave the name AX. Along y-axis, I give the name AY. Correct? So vector A is given by AX plus AY. This I can write it as IAX plus JAY. What are these I and J? These are the unit vectors along X and Y axis respectively. Correct? Then I can say AX is equal to IAX and AY is equal to JAY. Correct? AX is IAX, AY is JAY are the rectangular components of vector A in X and Y plane. Rectangular components of A and A in X and Y plane. Correct? So what is the magnitude over here now? I can say the magnitude will be AX square plus AY square. Correct? Suppose I say this angle is theta. Correct? Then I can mention that tan theta is equal to AY by AX. Clear? Correct? But if at all, instead of two-dimensional, that is X and Y, suppose I have A in 3 dimension, how will I write vector A to be? I will write AX plus AY plus AZ, which will be IAX plus JAY plus KAZ. What are they? They are nothing but my IJK are the unit vectors along X, Y and Z axis respectively. Correct? So in this case, what I can say, AX is equal to IAX, AY is equal to JAY and AZ is equal to KAZ are the rectangular components of vector A in XYZ axis, on XYZ axis. Correct? In that case, the value of mod of A will be under root AX square plus AY square plus AZ square. In this way, we can write it very clearly. Correct? Next, we will try and write